Alan Turing came to Manchester in 1948. The university was changing rapidly following the war. In physics, Patrick Blackett had just received his Nobel Prize. Turing's friend Max Newman was Professor of Mathematics. Manchester already possessed a working computer, developed from wartime work by F.C. Williams, the new head of electrical engineering, and his colleague Tom Kilburn.
The original team was Tom Kilburn, Jeff Tootill and Alec Robinson. And they were joined by a character called Tommy Thomas and myself, who were both research students, ex-physics.
The team developed a more powerful machine with the Ferranti Engineering Company. Launched in 1951, it was the world's first commercial computer. A new laboratory was built to house the university's machine. This was home to Turing and his students.
You started with a numerical problem to be solved. For instance, in my case, an equation which could only be solved numerically. And then you wrote a computer program. You went downstairs to the anteroom, and there you typed on a teleprinter your program. And you booked a slot, and when your turn came, you were allowed a maximum of 1 hour on the machine.
Turing had a small role in the design of the computer, but he was far more concerned with what it could be used for. His big interest was in morphogenesis, how patterns develop in living things, like the spots of a leopard. He saw a possible mechanism in the chemical theory of reaction diffusion systems. One of the leading experts was a Belgian chemist, Ilya Prigogine, who came to Manchester in 1952 to discuss Turing's ideas.
I have in my diary for that day, Turing versus Prigogine, ! And this was because at the end of the lecture, once Turing had finished, Prigogine more or less got to his feet and rubbished the whole of Turing's theory.
But Prigogine's group had no computer to perform the complex calculations Turing had relied on. The usefulness of Turing's approach was confirmed by later discoveries, such as the spectacular Belousov-Zhabotinsky reaction. Turing also discussed morphogenesis in plants with the Professor of Botany, C.W. Wardlaw. Turing had many such academic connections, though he could sometimes be hard to follow.
He was thinking so fast that when he spoke, odd words were missing. They were just left out. And it took a little bit of time to get used to that. He was very pleasant, and as a result of us, Tommy Thomas and myself, working nights to help run the machine for him, he invited us out to dinner at his house in Hanforth. And we had a very pleasant meal there, and we discussed all sorts of subjects, from gardening to the effect of magnetics on the brain, and so on.
The brain was Turing's other great interest. If the simple machines already played chess, perhaps more advanced computers could be truly intelligent. This question led to fierce debates involving Max Newman and other Manchester colleagues, Sir Geoffrey Jefferson, the leading neurosurgeon, and Michael Polanyi, the eminent chemist, now turned philosopher.
Turing at the time made a comment that, he was going to pursue research to find the extent to which a machine could actually think.
Turing proposed a simple test. Let an observer question a man and a machine without being able to see either. If the observer could not tell which was which, it was only fair to say the machine must be thinking. In his 6 years in Manchester, Alan Turing drew together many different fields of interest, but there was one crucial area he could never discuss. In 1952, he was convicted of gross indecency after admitting to sexual activity with another man. Sentenced to a course of hormone treatment, he worked on, but in June 1954, his life came to an abrupt end.
Certainly when he committed suicide, we just couldn't believe it. It was a tragic event, really. Such a waste of a life.
In his life and research, Turing struggled to communicate ideas which were far in advance of their time. 60 years on, the work he shared here is recognised as a major source of inspiration for Manchester and the world.